Hi, welcome to the walkthrough video of question 2, the Phoenician scheme of Spring 26 final. So we're given this linked list S that they give us the pointer diagram for the linked list. And then I think a good idea would be to represent this list in the scheme syntax. So I'm gonna just go ahead and use this to represent our list S. And then we can see the first element is a doubly nested list of 2, or we can write it like this. And then our second element is just the integer 0 inside S. And then third, we have this nested list of 1. So yeah, we just wrote out our representation of S. And then let's go ahead and look at part A. Part A says use only S parentheses and car and cooter to write an expression that returns 1. And we want to write car and cooter in uppercase. So we can see that in this list, 1 is represented here. And then somehow using car and cooter, we want to go ahead and locate the 1, right? So that we can go layer by layer, and we know like our most inner parentheses is the procedure that we're going to evaluate first, and then we go layer by layer out. So we know that we first want to eventually get to our third element, and then we want to get from the list, this third element, we want to get the first value of it. So now let's start with getting to that third element first. So we start with cooter, which means kind of like link.rest in Python. So for this whole list S, if I write cooter of S, that's going to give me a list of 0 and nested list 1. So that I'm still not at the third element yet. So I want to cooter again to have this cooter list only have our last element. So at this step, I'll return a list with a nested list of 1. And then I eventually want to get rid of the nested list, and I want to get to the integer 1. So then we can use car, which is kind of like link.first in Python. And this would just give us the first element of the list, which is a nested list of 1. And then we figure out this is still a list, so we need to car again in order to get our integer 1. So yeah, this is the solution for part A. I'll just clear this out to make the writings more clear. So we have car, cooter, cooter of S. And for part B, we're asked to use the numbers, parentheses, cons, and nil if needed to define S. So we're trying to construct this list over here. And remember what cons does? It's kind of like the link keyword in Python, which we specify first our first element in the list, and our second element would be the rest of the list. And it has to be a list. So I guess cons is a very helpful tool that we can construct the list, and we're going to use it for this part. So we can go ahead and write down cons in a pair of parentheses I already wrote here. And then remember our first argument should be our first element in the list, which in this case will be a nested list of 2. And we're going to construct it first. So to construct the list here, we're still going to use cons again. So let's write down cons. And we realize that for this list, our first element should be the nested list of 2. So our first element should also be a cons. And the nested list has the first element of 2. And this list only has 1 element. So our, I guess, rest of the list would be nil, which is kind of like link.empty in Python. And then after constructing this nested list of 2, we realize that the outer list right here still only has one element. So our rest of the list is also nil or an empty list. And this set of procedure calls would construct us the nested list of two. And then now we want to construct the rest of the list. So the rest of the list, as a list, we have 0 and then a nested list of 1, right? So that we can go ahead and construct that as well. So we're still going to use const. In this case, we can just go ahead and write our first element, which is 0. And then we have to go into our rest of the list as well. So for the rest of the list of this list of 0 and nested list of 1, our rest is a nested list of 1, right? And then we're going to construct it. So similarly to the nested list of 2, we're going to use const, and then we need a nested const to create that nested list of 1. So we have const as the first element is 1, and then our, since it's only a list of length 1, our rest of the list is nil. Similar for the outer layer of const, it's still nil because the nested list also only has length of 1. And then we can just go ahead and close our parentheses. So, sorry. This list is closing the parentheses with this first const, and then we have to close the parentheses, or we already did in the end, close the parentheses for our very first const. And this is how we do part B. Then let's go ahead and do part C. So part C says we can use numbers, parentheses, and the list keyword to define S. And we should not use quote or any single quote character. So this case, it's testing on the list keyword, which is kind of like Python. If you're just defining a regular list, you're writing like a square bracket, and you just specify each element inside your square bracket, right? So with the list keyword in Scheme, you're just going to write the word list, and then you're just going to list out your elements. So like 1, 2, whatever. So here, we're just going to use that keyword to construct our list as. So here, we can write down list, and then we're going to put our first element here, second element, and third element, each listed inside our call to the list procedure or list keyword. So let's do the nested list of 2 here. So since it's a nested list, we have to use list again and again because it's doubly nested. So this part in the middle, list 2, gives us a list of 2, and then the outer list call would give us the second layer of the nested list of 2. So this part would construct us the nested list of 2. And then for the 0, it's more simply, we just write down 0 as we're listing our elements. And for this list of 1, we're going to use list again, and that would just be 1. And this is how we do part C. Let's move on to part D, which we're again defining S, but we're only allowed to use numbers, parentheses, and quote, the word quote instead of the single character quote, and we're going to use that to define S. So remember for quote, we're just going to return kind of like the string representation. So whatever like characters we write down, whatever words or symbols we write down, we're just going to return it as is. So after using quote, we just directly want to return like what we wrote down at the beginning, what this list looked like in Scheme syntax. So we can just write the word quote and just copy down this list So instead of evaluating this whole expression, it would just return it as is, which is what we wanted. This is the list we want what the return to look like. And then for part E, we are using only number one, the parentheses, back quotes, or this is the shorthand for quasi-quote and comma, and this is a shorthand for unquote. So this question is testing our understanding of quasi-quote. So remember, the back quote just means, oh, we're starting to create a quote or starting to create a quasi-quote. And then for the comma are the expressions we want to evaluate. So remember, for the quote in part D, we don't evaluate anything at all. We're just going to return the expression as is. But for quasi-quote, we are still going to evaluate something, which specifically is something that has a comma in front of the expression. So let's go ahead and start a quasi-quote. So the reason why we need some unquotes here in this expression is because we're only allowed to use the number one. But you can see our list has two. Sorry, I erased the big list. I'm just going to write it again. 0 and 1. So we can see that there are twos and zeros that's not exactly one. So we can't just use a like regular quote because that would not give us 2 and 0 if we're only allowed to use one. But from quasi-quote, we can just evaluate some math operations so that we can get the number 2 or 0. So it's very similar, or kind of similar to part D, that we're just going to quote everything. So our parentheses is just like trying to recreate what we want this list to look like. So we have this nested list of 2, but instead of writing 2 here, which is not allowed, we want to evaluate something that equals to 2. So we can just do comma, which means evaluate, and we can do 1 plus 1, which will give us the 2 here. And we can then close our nested or doubly nested list. And then our second element of the list S is a 0, which we still are not allowed to directly write that number. So we can, again, evaluate some math. So we can do -1, 1. That would give us 0. And then in the end, we don't need to unquote or evaluate anything because we're just allowed to write down the nested list of 1. And this would, after evaluating the unquotes, this would give us the list of the correct list we want to look at. So yeah, that's part E. And then we're going to part F, which is like a more challenging part. So we're asked to define S, but using this repeated higher order function that takes in the function F and the number N. And this should return a function g of x that calls f on its input over and over again n times. So here's an example. If we have n equals 3, then g of x, which is what repeat would return, should be like the call of 3 nested calls to f. And if n is 0, g of x should just return x itself. And we're asked to fill in this blank to help define the list S, and our solution should use repeat, and it should process the input list 201, which we use as the list, the quote symbol here, which just means our input in the list, it has the element 2, 0, and 1 exactly. So for the repeat function, we can see the doc test here. So we first define a procedure called +1, and then that would just plus the whatever our parameter was 1. And then if we repeat this 3 times, this would like +1 3 times, which would give us, for input of 10, it would give us 13, which is 10 plus 1 3 times. This question can be very, very challenging after you read like this the question description. I know it also scares me out for a little bit when I first saw it. But I think we can just observe our input list and our target list for a bit. I can just move our target list down here. And there's one thing that we can kind of use in our solution is that we can see our like numerical values in this list also represent how many layers the list is nested in our list S. So we can see our first element is 2, and 2 is exactly nested 2 times inside our list S, and then 0 is nested 0 times, and 1 is nested 1 times. So this can actually help us in determining what number to kind of input in our calls to repeat. So we can use a very helpful built-in scheme procedure here is called map, which would iterate through each values in the list, and then it would call a function on this list on the individual elements. So our input list will be 201, meaning map would pass in 2 to a function here, and then 0 to a function here, and then 1 to a function here. And it would construct a list using what is returned by the function call, right? And I think the tricky part is what this function should be. So we want to create like a one argument function for map, which is like what map needs. So we can go ahead and define our lambda. And then what we want to return is a call to repeat. And we know repeat takes in a function. So this should be a function, which we'll determine later, and the number of times we want to repeat. So kind of like in logic or in pseudocode, what we want to let this repeat function call do is that it would call something that creates just an extra layer of nested list, and we want to just create a extra nested layer n times, because we can see like each element created or represents how many layers there should be. So for our repeat, our function f should be something that creates the nested layer, and then we input our value in the list, which we can just name it n, and it will just take in, or n will be 2 at first, and then 0, and then 1. So what is the keyword that we should use? I mean, for list, we have cons, append, list. What is the keyword we should use to create that extra nested one? And the answer here should be list, because every time we call list to some value, we just create this extra nested layer. So if we do like list of 2, that would just give us 2. And if we do like list again, that would just give us nested list of 2. So list should be what we passed in as f for this function repeat. And overall, this line would construct us the list S. So yeah, this is a very interesting question. We can see we're constructing a list in so many different ways, and it really tests our understanding for scheme list. And we can then move on to the last part of this question, part G. And here we want to define a scheme macro that should simulate Python's list comprehension. So we can see it gives us a example of comprehension. So it has like 10 times x for x in this list, and we have the predicate if x greater than 3. So here we can see 4 and 5 are greater than 3, and they were constructing a list with values of 10 times x, so 40 and 50. And then they give us some hint on using map and filter, which map returns a list constructed by calling this function in one argument procedure and on each element in list. And then we have filter, which should return list of consisting only of the elements in the list that returns true when being called on the predicate, which is a one argument procedure that returns a Boolean value. So Now we're asked to complete this macro definition. So by looking at this question, we can see there are kind of two types of multiple choice. So one type is that we choose whether there's a quote or a comma. So like something we want to evaluate in macro, or blank. And then there's two cases that we want to choose between map and filter. So a review for macro will be we're trying to construct this scheme line of code that we will pass in these parameters as is, or this argument as is, and then we'll evaluate them only after we make the call. So here we're seeing a bunch of list keywords that is just us trying to construct these scheme code as a list. So I think it would be helpful for us to kind of write the representation in like the resultant scheme code with like without these list keywords. So I'm just gonna write here we can have like some symbol or quote comma, have map or filter. And here we use a list keyword again, just showing us trying to create a nested list. So just a pair of nested parentheses. And we have a lambda, list again, another nested parentheses in our scheme line of code. Right? And then we have this unquote. That means we do want to evaluate the expressions later after in this macro. So we're asked to choose so we then have this quasi-quote, which means later on we're in this quote format, so we no longer need to like use list. Since we're in a quote, we're already seeing this statement as is, except when we probably need an unquote if we want to evaluate something. And we're still asked to choose our map versus filter here. And then since it's quoting, we're just writing it as is. It's nested parentheses. I'm gonna write it in the next line. Right. So then we can just start kind of approaching this question. I suggest we start by picking this map versus filter first to get our logic for this question straight. So first, for Python list comprehensions, we first decide, like for the predicate here, if x greater than 3, we first decide kind of which elements here in 2, 4, 1, and 5 are greater than 3. And then we pass in whichever is left, which would be 4 and 5. And then we would pass into the procedure we want to do, like 10 times x here. And then we would evaluate that expression and put it in the new list we're trying to construct. So in this case, in the scheme code, we're trying to do something very similar. So that would be mapping some procedures onto a list that's already filtered based on the predicate. So with that in mind, we can choose map for our, I guess, first choice we want to make, and then choose filter. In the second place, we have to choose between these two. And why is that? It's because if our, I guess, more outer call is a call to map, and this input list we have for map is some call to filter, which means our inputted list for map is already filtered out based on the predicate, then we can just call map the procedure, and then we're done. So this is exactly the logic I was going over for this Python example. And then with that in mind, we can just think of for the all these other choices, we're picking between quotes, comma, which is unquote, and then, or we do nothing. So we first have filter. Filter, so filter is not a parameter we have. It is like a built-in list procedure that Scheme give us. So, but we don't really want it to be evaluated inside a macro. We wanted to treat it as kind of like as is until we finish constructing this whole like line of code, and then we'll evaluate it together. So in that case, we want it to be a quote. And then we have this lambda. So similarly, lambda isn't a parameter, and we don't want to evaluate it yet. We want to quote it for now and then evaluate it later when our parameters are passed in and when we finish constructing our line of code. And then we have this SYM and we have this expert. These are parameters. These are, so the FYM would be our original list and our expert is kind of like the 10 times X, like what we want to do to each elements in this list comprehension. So these are our inputs. So these inputs are already not gonna evaluate it yet because we're in our macro. And then we don't want to quote them because we don't want our constructed line of code to just be saying, oh, SYM, like literally these three letters. We do want to put in, so for this lambda, we do want to put in this SYM we passed in or being customized by the user. So in this case, for macro, we would just make it blank. And similarly for expert, we want it to be the expression that the user specified, or the whoever calls the function, what the function call specifies. And then we have this 6 blank, which we're already in our quasi-quote. So in our quasi-quote, we know like, unless we unquote it, everything is quoted. So for this like filter function we later want to call, we know we want it to stay as a quote. So in a quasi-quote, that means we just leave it blank. And similarly for lambda, we want it to stay as a quote as well. Similar reason as the previous part when we used lambda, but here since we're in a quasi-quote, staying it as a quote means blank. But then for SYM, predicate, and vowels, those are our arguments in this macro or our user inputs. And this, we want them to be whatever the function call specified, right? So that means in a quasi-quote, we want them to unquote so that they actually, when calling this macro, it would be what the user passed in as an expression. So this would finish this part G, and it's finishing the whole question too. I know this is a pretty long and confusing question. So if you have any questions, feel free to come to office hours or ask on it. Thank you.